Now we move from the business view to the place where business expectations start becoming much more concrete. Data and application architecture are often where organizations begin to feel the consequences of unclear business logic and models. You may see duplicated data structures, overlapping applications, unclear source system, or reports that depend on data nobody fully owns. At the same time, data and application cannot be governed separately from the business context we discussed earlier in this course. So in this topic, we will look at how governance helps connect data structures, application landscapes, ownership, requirements, and business use into one aligned architecture view. In this lesson, we will make data and application architecture governance more concrete. I will not ask you to think as data architects or application architects. Instead, I want you to see what must be in place so these capabilities can be governed, maintained, and connected with business architecture and other data management practices. As we go through the lesson, you will recognize where architecture professionals lead the work and where business, data governance, stewardship, and application professionals need to participate. Let me remind you of what we covered earlier about architecture types. The tag of standards separates enterprise architecture into business, data, application, and technology architecture. This separation is useful because it helps us see which architecture areas is responsible for which type of structure and decisions. But in data management, the picture is not always so clean. Dema Dembok, for example, treats data modeling and design as a separate data management capability. TOGAF looks at the deliverables of data modeling as a part of data architecture. So depending on the framework, the same artifact may sit in a different place. And when we work with structured data, this becomes even more practical. Data is stored in applications. It moves through applications, is transformed by application logic. That's why in this topic I may also use the broader term information systems architecture. It helps us discuss data and application architecture together. The goal is not to debate terminology. The goal is to understand what needs to be governed when data structures and application structures are so closely connected. Let me briefly bring back a concept we discussed in another course, the data product. I use it here because it helps us see why data and application architecture are so closely connected. At the same time, we need to be careful with this term. There is no single standard definition of a data product. Different sources describe it differently, and in this course about data products, we discuss these differences in much more depth. For now, I want to use this picture only to clarify the scope of our discussion. The coral-colored components represent the subjects we will connect with data and application architecture. Data and metadata are clearly part of the data side. Software applications, databases, pipelines, and machine learning models bring us into the application and implementation side. You can already sense why separating data architecture from application architecture is difficult in practice. Structured data doesn't exist in isolation. It's stored, processed, moved, and used through applications and software components. So in this topic, we will look at these coral-colored components as the core scope of data and application architecture governance. Everything what is colored blue relates to IT-related topics. Now let's move from the data product view to the broader information systems capability map. You can see that this capability includes several lower-level capabilities. Some of them focus on requirements, glossary, classification, and modeling. Others deal with applications, integration, interoperability, orchestration, and implementation control. Together they show how structured data is defined, modeled, stored, moved, and used through applications. But again, our scope in this course is narrower. We are not designing all these information systems capabilities in detail. We focus on the governance sub-capability. So the questions becomes practical. Which artifacts should exist? Who approves and maintains them? Which rules and processes keep them consistent? How do they connect it with business architecture and real implementation work? This governance view matters because data and application decisions rarely stand alone. They depend on requirements, models, classifications, glossaries, applications, integration patterns, and control points working together. Let's briefly repeat the methodology we use to design any capability. We start with its purpose, because purpose explains why the capability exists. Then we define the outcomes, because they show what success should look like. After that, we identify the outputs that make these outcomes visible. These outputs need inputs, and processes transform those inputs into the expected results. Around the processes, we define the enabling components, rules or policies, roles, tools, and supporting assets. This logic helps us avoid designing isolated pieces. Instead, we build the capability as a connected structure that can be governed, performed, and improved. Now let's look at the information systems capability across three organizational levels. This slide is important because the work is not the same at each level. At a strategic level, the organization defines the direction for information systems architecture. This is where principles, priority domains, investment priorities, the transformation roadmap, and the program or project portfolio are agreed. So the strategic level creates the why and the where we are going. Then the technical level makes this direction manageable. This is where governance is established and information systems activities are coordinated. Policy standards, processes, RICI, matrices, tool requirements, and the control framework help keep different programs and projects aligned. Without this layer, teams may work hard, but each project can still move in its own direction. At the operational level, the role becomes very concrete. People design, implement, and maintain the actual architecture artifact. This includes requirements, glossaries, data models, catalogs, matrices, flows, classifications, applications used, and integration documentation. So the logic is quite clear. Strategy sets the direction. Tactical governance creates coordination and control. Operational work delivers the artifacts that make information systems architecture visible and usable. Now let's clarify the purpose and outcomes of the information systems capability. I want to separate outcomes from outputs because this distinction matters. A data model, a catalog, a matrix, or an application view is an output. It's something that the capability produces. An outcome is different. It shows what becomes better for the organization when these outputs are actually used. So the purpose of the information systems capability is to make structured data and applications work together in a way that supports operations, decisions, and change. One outcome is that business users can access and use reliable information across the applications and processes they depend on. Another outcome is better change control. When data applications or integration change, the organization can assess the impact before disruption happens. The third outcome is reduced fragmentation. Over time, data and application landscapes become more consistent, easier to reuse, and easier to govern across initiatives. Before we move further, let's briefly look at what this course gives you as a data governance professionals at different levels. If you work at the strategic level, you can better see where data and application architecture create risks or opportunities for business to technology alignment. You can also recognize which architecture decisions need governance attention before they affect data strategy, ownership, funding, and transformation priorities. If you work at the technical level, the course helps you coordinate data governance participation and architecture discussions. You can connect standards, ownership, requirements, controls, and review processes with data and application architecture work. And if you work at the operational level, the course helps you see where your daily input matters. Definitions, rules, data issues, requirements, lineage, and usage evidence all help architecture professionals make better decisions. So whatever your level is, the course helps you hear architecture conversations more clearly and understand where your governance contribution belongs. Now let's look at the artifact that the TOGAF standard foresees for information systems architecture. I group them into 4 practical categories because otherwise the full list can feel difficult to use. The first group is organization related. These artifacts help us understand who uses the systems, where users are located, which business functions are involved, and which roles participate. The business reason is simple. Applications and data should support real organizational work, not an abstract technical design. The second group is data structure related. Here we see glossaries, data models, diagrams, and data flows. These artifacts help people understand what data means, how it's structured, and how it moves. The third group is application related. These artifacts describe applications, interfaces, communication, interaction, and migration. They help the organization see how systems work together and where changes may create dependencies. The last group is technology related. These artifacts describe services, networks, processing components, computing components, and communication infrastructure. Their goal is to show what technical foundation supports the application and data. So each group serves a different purpose. Together, they help you see information systems architecture as a connected view of business use, data structure, application behavior, and technology support. When we design information systems architecture, I wouldn't start by asking for a new model or catalog. I would first sit with the team and look at the material already available. Existing data and application artifacts tell us what the current landscape really looks like. Then the business strategy helps us hear why this landscape needs to change. From there, regulations and policies bring the boundaries into this discussion. They show what the architecture has to respect. Organizational structure, business functions, and roles at the human side. They clarify who works with data, who uses the application, and where accountability sits. Only after that do the outputs make sense. Models, catalogs, flows, and application use can then reflect business direction, system reality, compliance, and ownership together. Now let's connect this part to something you probably experience in real projects. People may agree that data and application architecture should be governed. But very soon the conversation becomes practical. Which rules do we follow and who uses them? That's where these 3 documents come into the picture. I would start with the Data and Application Architecture Policy. This document gives everyone the same high-level direction. It clarifies the scope of governance, the decisions that need control, and the roles that should be involved. It also keeps data and application connected with business needs. But then the discussion moves into the details. A data architect may ask how customer product or transaction data should be modeled. A data steward may want to know where definitions, ownership, and classifications fit. This is why we need the data modeling standard. It gives practical rules for modeling levels, naming, ownership, review, and change control. Then the application side brings its own concerns. Applications need classification, integration rules, security principles, lifecycle control, reuse logic, and change management. The application architecture standard gives structure to those decisions. So I want you to see this document as a connected set. The policy keeps the overall direction clear. The data modeling standard makes the data side consistent, and the application architecture standard makes the application side consistent. Together, they help professionals stop solving the same architecture questions project by project. Instead, people can work from shared rules and connect data and application decisions more reliably. Now let's look at the examples of processes that can deliver the core information systems architecture artifacts. I use the word can deliberately because organizations may structure this work differently. Still, the logic usually starts before design begins. People first need to align requirements with the business glossary. Otherwise, a model or an application design may look technically correct, but the business meaning behind the data remains unclear. Then comes data modeling and structure design. This is where data architects and modelers shape the data into conceptual, logical, and physical models. From there, application architecture and interoperability becomes important. Applications need to work together, exchange information, and support business processes without creating unnecessary complexity. Then we need to see how data actually moves. Data flow, lineage, and integration design help people trace where data starts, how it changes, and where it's used. Governance, quality, and security controls bring another layer. They help ensure that the architecture is not only functional, but also reliable, protected, and compliant. And because architecture never stays still, review and change control keep these artifacts alive. When requirements, systems, models, or integrations change, the architecture needs to change with them. So these processes help the organization move from scattered technical work to a governed architecture that people can see, hear, discuss, and maintain. So once these processes are defined, the next thing I usually ask is very simple. Who keeps this work under control? Because in information systems architecture, one person rarely has the full picture. Think about requirements and glossary alignment. The business domain owner understands the business context, and data governance helps keep meaning, ownership, and rules consistent. Then, when the work moves into data modeling, the data architect can shape the model, but the steward often hears whether the definitions really make sense for the business. Application architecture brings another perspective. Application owners, solution architects, and integration specialists understand how systems behave and where dependencies appear. And when we talk about flows and lineage, we start connecting these perspectives. We need to see where data starts, how it changes, which application touch it, and where people finally use it. Quality, security, and compliance then add the control lens. They help us sense whether the architecture is not only designed, but also safe and usable. Finally, review and change control keeps the whole picture from becoming outdated. So the information on the slide helps us hear one message. Accountability keeps the process controlled, and responsibility brings the right knowledge into the work. Now let's look at how the information systems capability involves people across the organization. At the strategic level, the discussion starts with direction. Executives and senior leaders approve priorities, principles, decision rights, and accountability for data domains, applications, integrations, and critical information flows. This matters because information systems architecture can easily become fragmented when nobody owns the bigger direction. Then the technical level turns this direction into coordinated work. This is where policies, standards, processes, controls, and participation models are shaped across domains, systems, and projects. You may recognize the situation. One project documents data flows, another defines application interfaces, and a third one changes a data domain. Without technical coordination, these activities may all look useful, but they may not fit together. At the operational level, the architecture becomes concrete. Professionals document requirements, glossaries, models, catalogs, matrices, flows, classifications, application details, and integration knowledge. This is also where inconsistencies appears first. A definition doesn't match the model, a flow misses transformations, an application dependency is not visible yet. So establishing the information systems capability is a shared effort. Strategic leaders give direction, tactical leaders coordinate the work, and operational professionals make the architecture accurate and usable. If you participate at the strategic data governance level, you are not expected to design application views or data models yourself. But you need to recognize when information systems architecture creates a governance risk. For example, a data strategy may look strong, while the application landscape still keeps critical data fragmented. Or a data owner may be assigned, but the related applications and information flows remain unclear. At this level, your role is to see these connections early. You look at data domains, critical information flows, application dependencies, and decision rights. Then you can ask whether the architecture direction supports governance priorities. This is also where escalation matters. When weak data and application alignment starts affecting ownership, investment, compliance, or transformation, the issue shouldn't stay hidden inside a project. So your contribution is strategic oversight. You help ensure that the data governance has a visible place in information system architecture decisions. If you work at the tactical data governance level, you are much closer to the place where architecture decisions become practical. You may hear architects discussing models, interfaces, applications, or integrations. At the same time, stewards may ask about definitions, ownership, lineage, and quality rules. Your role is to help these conversations meet. You connect glossaries, catalogs, lineage, classification, and ownership work with information systems architecture activities. That means you do not only review artifacts after they are created. You help bring governance requirements into the design conversation earlier. For example, when a data flow changes, you can sense the impact on lineage, ownership, quality controls, and stewardship work. When a model changes, you can help check whether definitions and classifications still remain consistent. So at this level, your contribution is coordination. You help translate architecture decisions into governance routines that stewards and business stakeholders can actually follow. If you work as a data steward or operational data governance professional, you often notice the details that architecture teams may not hear immediately. A term may look clear in a glossary, but people may use it differently in daily work. A lineage view may look complete, while one transformation step is still missing. A data model may describe the structure, but the real usage may tell a slightly different story. This is where your contribution becomes very practical. You bring definitions, rules, ownership input, classifications, data issues, and usage examples into information systems architecture work. You also help validate whether Glassware entries, catalog records, flows, and lineage really reflect what happens in operations. And when something no longer fits, your input can trigger review or change control. So you are not replacing data architects or application architects. You are helping them see whether the architecture artifacts still match business meaning and real data usage. That's how operational governance keeps information systems architecture accurate, usable, and alive. Let's now talk about the tools that enable documenting and delivering information systems architecture artifacts. Let's separate the tooling more carefully here. For the information systems architecture capability, one tool category is not enough. An enterprise architecture platform helps people see the broader picture of applications, dependencies, architecture views, and impact analysis. Then for data modeling, we need a more specialized tool. This is where conceptual, logical, and physical models are created and maintained. A metadata management or data catalog platform plays a different role. It helps people connect glossary terms, metadata, classifications, ownership, lineage, and data assets. And then we also need tooling for the application and integration side. Application inventories, APIs, interfaces, integration patterns, and dependency views help people understand how systems work together. So the tools support different parts of the same capability. Together, they help professionals see, structure, connect, and govern data and application architecture more reliably. Let me bring this back to what you may face in your organization. You may hear people asking for better data models, clearly catalogs, visible lineage, and more reliable application views. I hear this request very often. But then I usually ask a simple follow-up questions. Where will the time, tools, and expertise comes from? Because architecture visibility doesn't appear just because people agree it's important. If you want information systems architecture to work as a real capability, the organization needs to fund the work behind it. This includes capability design and governance setup. It also includes the right tools, because enterprise architecture platforms, data modeling tools, metadata platforms, and integration tools support different parts of the architecture picture. But I want to pay special attention to people's time. If architects, data professionals, application owners, subject matter experts, and stewards participate only when they have a moment, the architecture will never stay reliable. And once the first artifacts exist, another question appears. How will you keep them current when models, applications, integrations, or requirements change? That's why maintenance, review cycles, and change management also need funding. So when you discuss financial enablers, do not think only about software licenses. Think about the full capacity needed to keep information systems architecture useful, trusted, and alive. Now let me summarize and bring this back to your role as data governance or data stewardship professional. Information systems architecture is not owned by data governance. Data architects, application architects, integration specialists, and enterprise architects lead many parts of this work. But your participation is still essential because information systems architecture directly affects data meaning, ownership, quality, lineage, and usage. If you work at the strategic level, your focus is on alignment and risk. You need to see whether data domains, applications, integrations, and critical flows support the data strategy and business direction. You also need to recognize where weak alignment creates risks for ownership, funding, compliance, or transformation. At the tactical level, your work becomes more about coordination. You help connect glossaries, catalogs, lineage, classifications, ownership, review routines, and change control with information systems architecture processes. This is where governance decisions become practical guidance for stewards and business stakeholders. At the operational level, your contribution becomes very concrete. You bring terms, definitions, rules, classifications, usage context, and issue insights into the work. You can help validate whether models, catalogs, flow, lineage, and classifications still reflect operational reality. So your role is not to replace architecture professionals. Your role is to make sure that information systems architecture remains connected to governed data meaning, real usage, and business accountability. Data Crossroads Academy will continue developing a series of courses for data governance professionals. This series will focus on the skills needed to participate in information systems architecture deliverables. We will look at examples such as business glossaries, data models, catalogs, lineage, data flows, classifications, application use, and integration documentation. The goal is not to turn data governance professionals into data or application architects. The goal is to help you participate with enough understanding to ask better questions, hear the risks, and support stronger architecture decisions. Congratulations! You completed topic 3 of this course. Now it's quiz time. Now I encourage you to perform a short exercise and perform self-assessment of the information systems architecture capability in your organization. For that, you need to download the checklist, and depending on your level of accountability, you should review this checklist. Good luck! If you are interested to move on with your career development in data governance, I invite you to join other courses of the Data Crossroads Academy. If we haven't met yet, my name is Irina Steinbeck. I am a strategic advisor and coach who finds clarity in complexity, and an author. My work focuses on governance frameworks for data, metadata, and AI management. What drives me is simple: turning complex concepts into practical, actionable strategies. I've been working in that data field for more than 16 years. Before that, I built my foundation in business consultancy, controlling, and project management. That background shapes everything I do. I always approach governance from a business perspective, not just a technical one. Over the years, I worked with global institutions across many different industries. Each experience taught me something new about what works, what doesn't, and why governance efforts so often stall before they begin. I found Data Crossroads and developed the Orange Data Management Framework. It's a methodology built on a real-world application, and I've shared it through 5 published books. I've also taken this work to international stages, workshops, keynotes, and conferences around the world. Everything I do is pragmatic and methodology-driven, and that's exactly the spirit you'll find throughout this course.